All right, in this section, we're going to talk about confidence intervals for proportion. Again, proportion means either percent or portion. For example, we talked about it before. Let's say I'm interested in knowing what percent of people in LA has coronavirus. So that's an example of a proportion. I will talk about how to estimate that by using a sample. This one corresponds to textbook section 8.3. So the best point estimate, again, point estimate means just one particular number or a single number. For P, which is the population proportion, is the sample proportion. We'll use this notation P hat, where X represents the number of successes. This is from last section, we talked about it. And N represents the sample size. From last section, we talked about confidence interval for the mean. That's when we have a quantitative data set. Quantitative data set is numerical value, so we can find an average, we can go from there. However, when we have qualitative data set, for example, all the yes/no question survey, we can't really calculate the average. However, we can calculate like a percentage of or portion of people who said yes. So this could be useful to analyze when we had qualitative data set. Okay, let's look at example 2. If 829 muggles are surveyed and 17% of them believed in magic. So you can see how the survey will say, do you believe in magic? Yes or no, right? So this is qualitative data set. And they surveyed 829 people and they figure out 17% of them believed in magic. This 17% is P hat, because this is a percent or proportion. They calculate it from a sample, right? Question is, how many muggles believe in magic? Again, it's a 17% of 829. So what I can do is 0.17, 17 converted to decimal, times 829. When you calculate this out, you get 140.93. Again, we're talking about like how many people. So I'll say 141. This will be my X, which is, I'm sorry, not X bar, just X. This would be number of successes. Okay. All right, recall the formula we have for the mean and standard deviation of binomial. Mean was n times p. Standard deviation was radical n times p times q. This is from binomial distribution. So what we can do is we can think of our survey yes/no question as like a binomial distribution, and we can kind of use that theoretically to come up with confidence interval or margin of error for our confidence interval. So we can approximate the binomial distribution with normal distribution if our sample size is not too small. In general rule, we can use the normal approximation to binomial if NP is bigger than 5 and Q is bigger than 5. So this is kind of theoretical, but basically what it says is our sample size has to be big enough for us to be able to form a confidence interval. So basically what it says is we need at least 5 yeses, and 5 no's. Yeses. So the way we're going to form confidence interval for proportion is going to be different than for the mean. It's going to have the same format, however, but it's going to be a different formula. So let us side note. For the mean, we have x bar minus margin of error, x bar plus margin of error, where the margin of error was z alpha over 2 times sigma over radical n. So the format is going to be the same. So instead of using x bar, we're going to use p hat. And instead of using sigma over radical n for the margin of error, we're going to use radical p times q over n. So instead of x bar minus e, we're going to have p hat minus e, margin of error, p hat plus e, margin of error. And margin of error is going to be here in the bottom, number 6 here, the error bound of proportion, EBP. Again, I'm going to refer to it as just E, margin of error. And the formula is going to be E is equal to Z alpha over 2 times radical P hat times Q hat all over N. And basically your confidence interval, CI for confidence interval is going to be P hat minus E, P hat plus E. Again, graphically, P hat is in the middle, and then you'll add E, margin of error, you subtract E, margin of error. So this will be your confidence interval. So our margin of error formula is different, but structure is the same as before. I want you to notice that instead of X bar, I used P hat, and margin of error had different formula. This is all because now we're dealing with qualitative data set. So we want to look at a percentage of people who said yes or percentage of people with a certain property. Number 7 just gives you like theoretical background. Again, this, since we're taking sample and looking at their proportion, we're looking at the distribution of sample proportions. Meaning, if I go out and survey a bunch of people, and if you go out and survey a bunch of people, we probably get slightly different answers. So if you look at all possible sample proportions we calculate, it's going to have normal distribution, and the mean and standard deviation is going to be like this. That's where the formula for margin of error that we talked about earlier, the standard deviation came from there. All right, so let's see. It says create 95% confidence interval with x is 20. That means that's 20 people said yes, n is 36, and they surveyed 36 people. So I'm looking at here, it's like, oh, this is number of yeses. This is my sample size. So I don't know what the question was, but they surveyed 36 people and 20 people said yes. First calculate EBP. Again, this is margin of error, and we want to find the confidence interval. Fine, okay. So let's first look at P hat. Again, like structure is gonna be like this. P hat is gonna be middle. We're gonna add E, then we're gonna subtract E, and then we're gonna come up with the confidence interval. So P hat is 20 out of 36, right? So if we calculate that out, 20 divided by 36 is 0.555 forever. For proportion or percentage, I'll usually round to the 3 digits. So 55555. So I'll round to 556. All right, so I got my P hat. But now next step is to find the margin of error E. Again, the formula is alpha over 2 times radical P hat Q hat over N. So let's do a little side note here. To find the Z alpha over 2, they said it was 95%. So we're going to do inf norm 0.9501 and the center. What we did, just like what we did before, you get negative 1.96, positive 1.96. I'll take the positive part. So 1.96 times radical P hat is 0.556 times Q hat is just 1 minus P hat. So a little side note, Q hat is 1 minus P hat, which is 1 minus 0.556. So it'll be 0.444. And then sample size n is 36. So when you calculate this out, you get 0.162. So it's margin of error, 0.162. So putting it all together, 0.556 minus 0.162 and 0.556 plus 0.162. So here we'll get 0.394 and 0.718. So my confidence interval is from 0.394 to 0.718, whereas my P hat, which is sample proportion, was 50.556. So the interpretation here is from my sample, 55.6% of people said yes. How about the entire population? we're 95% confident that proportion for the entire population is somewhere between 39.4% to 71.8%. All right, now I'm gonna look at a shortcut. So it takes a lot of steps to get the confidence interval, but luckily we have our calculator, and our calculator has a function key that does it in one step. And you might have noticed already from z intervals. So what we're gonna do is gonna go to stat, then we'll go to tests. They're gonna scroll down to option A, one population z interval. So this one is a long name. We have one proportion, PROP, z interval. So PROP is for proportion. Our formula has z score in it, so it's z interval for confidence interval. Once you click that, it asks for x, which is number of successes, n is the sample size, and the C level, which is the confidence level. All right, I'm gonna have you pause and work on number 9, and we'll meet back at number 10. All right, for number 10, here is asking for minimal sample size. Again, this is when your margin of error is given. I want a certain margin of error, and they're asking how many people I need to survey. So this is to find how many people we need to survey, how many we need to survey. Right? So when sample proportion is given, and the sample size is going to be p hat times q hat times z alpha over 2 over margin of error e, the whole thing squared. When the sample proportion is not given, basically what we're going to do is we'll use p hat to be 0.5, q hat, that means q hat is also 0.5 because that's 1 minus 0. P hat. So p hat times q hat will be 0.25 times z alpha over 2 over e, the whole thing squared. So either I use this when p hat is given. If that's not the case, I'll use that. And again, we'll round up because it's the number of people, so it has to be a whole number answer. Okay. All right, I'm gonna have you pause and finish the rest of the worksheet.